Hello friends, welcome back to my YouTube channel. So in this lecture, I am going to discuss about one of the very important factor that actually decides the strength of acidity of different compounds, and that factor is called the inductive effects. Okay, so before going into the details of what is called inductive effect, let me show you this molecule. Okay, so you can see that the name of this molecule is called the ethyl fluoride. Okay, so this group is called the ethyl group. Okay, and this group is called, and this is fluorine atom, so that's why we called it ethyl fluoride. Okay, now we know that this fluorine atom is much more electronegative than carbon atom. If you go to the periodic table, then you will see that this fluorine atom is much more electronegative. So what is electronegativity? Electronegativity means the capability to draw the electron density towards itself. Okay, so as this fluorine atom has very high electronegativity, so that's why this fluorine atom will try to draw more electron density towards itself. Okay, so you can see that this carbon fluorine bond is basically nothing but a type of covalent bond where carbon and fluorine share each of its valence electrons to form the covalent bond. But as this fluorine atom is much more electronegative than carbon atom, so that's why this fluorine atom has very high tendency to draw more electron density towards itself. Okay, so that's why some partial negative charge will be formed above this fluorine atom, and as this carbon atom will be partially electron deficient, so that's why one partial positive charge will be formed above the carbon atom also. Okay, now as you can see that due to the presence of this partial positive charge, this carbon atom will also become bit more electron deficient, so it will also try to compensate that electron deficiency from its neighboring carbon atom. So to compensate this electron deficiency, it will also try to attract or try to gain more electron density from this carbon atom, so it will try to draw more electron density towards itself. Okay, so that's why this carbon atom will also become partial positive, so some delta positive charge will be formed, but this delta positive charge or this delta dash will be much more lesser than this delta, because this carbon atom is just adjacent to the fluorine atom, so that's why this delta value or this deficiency on this carbon atom will be much more higher than the deficiency on this carbon atom. Now if you go to the basics, then you will understood that this the deficiency on of electron on this carbon atom is formed due to the presence of this fluorine atom only, because as this fluorine atom present here and as it is drawing electron density from this carbon, so that's why this carbon atom become electron deficient, and to compensate the electron density, it will also try to attract or draw more electron density from this carbon bond. So you can see that this effect of this electron withdrawing power of fluorine is shown in this carbon bond also. So that's why we are calling this effect as inductive effect. So basically this inductive effect is basically a type of electronics effect which is transmitted through the bond. Okay, so you can see that in this case the effect is transmitted through carbon fluorine bond, and in this case the effect is transmitted through carbon bond. Okay, so this fluorine atom basically induces one positive charge on this carbon atom and another, or we can say partial positive charge on this carbon atom and another partial positive charge on this carbon atom. So that's why we call this effect an inductive effect. Okay, so I think now the idea of inductive effect is bit more clear to you. Okay, so this inductive effect can be of two types. Here I have shown you the example of electron withdrawing inductive effect. where fluorine atom is much more electron withdrawing in nature, and it will try to withdraw more electron density towards itself. So that's why it will induce some partial positive charge on its neighboring atom. But there can be another type of inducting effect, that is called electron donating inductive effect. So instead of this types of electron withdrawing atom, there can be some atom like A which will try to give or donate more electron density to another atom that is bonded with this electron withdrawing atom. So in that case, this atom will possess some partial positive charge, and the atom which is just adjacent to it will have some partial negative charge. So, basically the total reverse situation will be there in that case. So that effect is called the electron donating inductive effect. But if you see in our case, most of the cases will be electron withdrawing effect. So this inductive effect is very much important to describe the acidity of different compounds. So in my next slide, you will understood how this inductive effect basically control the acidity of some compounds. Okay, so based on this inductive effect, we have to decide whether a compound A is more acidic or compound B is more acidic. That you will understood. Okay, so you can see that another thing I have just told you in this case. So this fluorine atom is just adjacent to this carbon atom. So that's why the positive partial positive charge that will be developed on this carbon atom will be much more higher than this one. Okay, so this delta positive will be always greater than delta dash. So you can see that the impact of this electron withdrawing inducting effect of fluorine will be much more to this C1 carbon rather than this C2 carbon atom. Okay, so you can see that this electron withdrawing or electron donating inductive effect weakens as the distance from this atom increases. Okay, so as it is basically as it is a type of electronic effect which is transmitted through bond, so as the distance from this atom from this bond increases, the electron withdrawing or donating inductive effect will also decrease. Okay, now here in this slide I will just describe you how the inductive effect basically decides the acidity of some compounds. Okay, so here I have described the pK value of some carboxylic acid, that is you can see this is acetic acid, and this is the pK value of methanol. Okay, you can see that the pK value of acetic acid is 4.75, which is much more lower or much lower compared to the pK value of ethanol, which has a pK value of 16. Okay, so in my older slide or in my older lecture, if you go to my older lecture, you will understood that this pK value basically indicates the strength of an acid. Okay, so lower this pK value, higher will be the strength of acidity of any compound. Okay, so which shows that this carboxylic acid will have much more higher acidic strength compared to this alcohol compound or methanol. But why it is so? We can actually describe why acetic acid is much more acidic than methanol by using this concept of inductive effect. Okay, now you can see that this carboxylic acid, when we put it in aqueous solution, this types of dissociation occurs. So this acetic acid become dissociated with acetate anion plus H3O plus. Now in my previous lecture I have described that the acidity of any compound will be decided by its stability of its conjugate ion. This is called conjugate anion. Okay, so if this conjugate anion is very stable, then we can say that this acid or this compound is much more acidic. So the acidity of this compound will be solely dependent on the stability of this conjugate anion. So here we will see how this acetate anion and this anion ethoxy anion, these two conjugates anion, we have to decide which one is more stable in nature. Okay, so in case of this methoxy ion, you can see that the negative charge is only on the oxygen atom. Okay, so the negative charge is only concentrated to oxygen atom, so that's why this types of anion is much more unstable in nature. So that's why you can see that this is as basically nothing but the conjugate anion that is produced when this alcohol is put in contact with some aqueous solution. So that's why this you can see that as this conjugate anion is much more unstable in nature, so that's why this alcohol will have much more lower acidity. Okay, on the other hand, in case of the this acetate conjugate anion, there are two types of stability that it could gain. So the first stability is called the resonance stability. So you can see that this structure 1 and structure 2, these two are equivalent resonance structure. So because of this two equivalent resonance structure, the electron density is not only reside on any particular oxygen atom, so it is basically distributed on this whole site. So that's why there is a resonance stabilization of this conjugate anion. On the other hand, you can see that there is another carbon oxygen, or you can see carbonyl bond just attached with this oxygen atom. So this electron density can be, or this electron cloud can be distributed through this inductive effect. Okay, so that's why this negative charge is basically shared by inductive effect as well as resonance stabilization. So that's why this conjugate anion has much more higher stability compared to this conjugate anion. So as this conjugate anion is having much more high stability, so that's why we can say that the acetic acid is much more acidic in nature. Okay, so you can see that how this inductive effect as well as resonance effect decides the acidity of any compound. Now here I am giving you some example. So you can see this is one compound and this is one compound. Now you have to decide, basically these two are nothing but carboxylic acid, where one carbon atom which is just adjacent to this carbonyl group, one hydrogen atom is basically substituted with fluorine atom, and in this case one hydrogen atom is substituted with bromine atom. Now you have to decide which one will be more acidic in nature. You have to compare the acidity. Now you can see that the conjugate anion, you have to actually see the stability of its conjugate anion. So this is the conjugate anion that is being produced. Okay, now you can see that this negative charge can be distributed through this inductive effect, that is carbon, due to the presence of this carbonyl group, and also due to the presence of this fluorine atom, because fluorine is much more electron withdrawing in nature, so it will try to withdraw this electron through this carbon carbon bond. Okay, on the other hand, bromine is not so much electron withdrawing in nature, or like fluorine, because bromine has much more lower electronegativity. So this electron withdrawing inductive effect in case of bromine will be much more lower compared to fluorine. So that's why this conjugate anion will be less stable than this conjugate anion, because this conjugate anion is stabilized due to the electron withdrawing inductive effect of fluorine atom. So that's why as this conjugate anion is much more stable in nature, the acidity of this compound will be higher compared to this compound. Okay, now if you compare the acidity of these two compounds, similar type of problem. Here you can see that the main difference is the position of the fluorine atom with respect to this carboxylic group. Okay, so you can see that in this case the fluorine atom is basically much more far away from this carboxylic acid compared to this compound, where this fluorine atom is just adjacent to the carbon atom which is attached with this or just adjacent to this carboxylic group. Okay, so as this fluorine atom is just attached with this carboxylic group, so it will impose more inductive electron withdrawing inductive effect to share this electron density on oxygen. So here the deciding factor is basically the proximity of this electron withdrawing fluorine group. So this fluorine group is much more near to the carboxylic group compared to in this compound, whereas fluorine atom is far away from this carboxylic group. So as there is a proximity of this fluorine atom to the carboxylic acid group, so it will impose more electron withdrawing inductive effect. So that's why this conjugate anion will be much more stabilized due to the close proximity of this electron withdrawing fluorine atom. Okay, so that's why this will be much more acidic compared to this compound. So these are the two examples that I have given to you. So these types of questions can be arised in your in any exams where you have to compare the acidity, where you have to be logical and try to find out what is the reason behind the more acidity of one compound compared to another compound. So here I am giving you two homework, so you can do this two homework on your own. So you can see that you have to just see which compound is much more acidic than another one. Okay, so you can see that this is the first one and this is the second problem. So you try to figure out on your own. If you do have any problem, you can comment down below. I will surely answer all your queries. So I am giving you some small hints. So the basic difference between this compound and this compound is the number of chlorine atom that is attached with this carbon atom. Here the number of chlorine atom attached is 2, and here the number of chlorine atom attached is 1. Okay, and you can see in this case the main difference between these two structure is the position of this fluorine atom compared to the carboxylic acid group. So these are the two hints that I am giving to you for these two problem. So you try to solve this two problem on your own, and if you do have any problem, please ask me through the comment section. So that's all from this lecture, where I have tried to give you a glimpse of what is called the inductive effect and how this inductive effect basically decides the acidity of any compound. So thank you very much for watching this video till the end, and if you do like my video, please subscribe to my channel Chembiosis. Thank you.